Thanks very much. Yep, I'm John Lees-Miller. I'm one of the co-founders at Overleaf. So I think the first thing I need to say is that for coming to this workshop, you can get a free Pro Plus account, which is the paid account on Overleaf. If you go to this website, www.overleaf.com/org/ISMB17, you'll get a 1-year free Pro account, which will help you try out Overleaf and also will be helpful in this workshop because we're going to do some interactive stuff. So if anyone has a laptop, I'd suggest getting your laptops out, making sure that they are on the internet and all that good stuff, and we can do some exercises with LaTeX coming up soon. So while you guys are getting that set up, I guess today I'm going to talk about Overleaf primarily. I'm going to go a very quick sort of intro to LaTeX. So if you're not familiar with LaTeX, we'll go right through the basics. If you're already familiar with LaTeX, there's also some more advanced material I can point you to. We're also going to then look at some of the more advanced stuff that we've got in Overleaf. So things like the Mendeley integration for managing your references, working offline with Git, and some of our other fun integrations. So there's that URL one last time. I would go there, make sure you get that set up. While you're doing that, a bit of history on Overleaf. So Overleaf started as a side project of mine about 5 years ago. My co-founder and I were working on the world's first computer-guided taxi system at Heathrow Airport. So if you ever go to Heathrow Terminal 5, you should check it out. It's a lot of fun. But this was a big pan-European sort of research project. There were a lot of stakeholders in industry, in academia, and basically a lot of math geeks like me working with a lot of non-math geeks. And we really struggled to find sort of tools that we could use to collaborate on papers and technical reports. So I decided to write one. So we were the first users, but now we have over 2 million users. We've written over 10 million documents on our products, and that's all happened in the last 5 years, so growing very quickly. A big part of that growth has actually happened in the last week, because we've now joined forces with Cherrylatech, which is another really awesome online LaTeX solution. So I'm also, for the first time, going to demo some Cherrylatech stuff, which I've been waiting to do for many years, so that's very good. What does Overleaf look like? It's basically like so in the middle you've got a sort of rich text view, a bit like Google Docs. It's collaborative, so multiple people can edit at the same time, and it'll synchronize all your changes. On the right-hand side, there is a real-time preview of the final typeset output, so you can see how your paper will look when it's published. And then on the left-hand side, you've got a sort of menu where you can upload figures and reference data, all that good stuff. For this particular document, it's set up to go to a particular journal. So there's also a Streamline submission link. When you're finished writing your paper, you can hit the Submit to Genetics button, and it will submit it to the genetics journal directly, rather than having to go through a big submission process, downloading and re-uploading and all that good stuff. Behind the scenes, that is behind the rich text view, there is the full power of LaTeX there. So everything we do is based on the venerable LaTeX typesetting system, which means that you're never locked into Overleaf. You can always download your work and compile it yourself with LaTeX. And it also means that you have the full power of LaTeX there if you want it. That begs the question, why would you want LaTeX? So we'll go through some more examples later, but particularly if you're a student or basically anyone who's submitting to a journal, you'll be familiar with this problem where if you're using Word, you have to sort of manually fiddle your margins, and then you get your thing rejected because there were a tiny amount out. LaTeX has really great support for templating, so you don't have to do that. You can let LaTeX do all the layout for you. You just focus on writing your content. Also, LaTeX enables you to use a lot of really powerful collaboration tools, such as Overleaf, so you don't have to send Word documents around by email with sort of funny titles like final version 2. It's a lot better to have things in the cloud. So that's, I think everybody feels that pain to some extent working on any kind of documents, but I think scientists have it particularly hard because our workflow is just really complicated. So you often have co-authors on your paper, so it's collaborative from the start, and then it goes through a whole other process of editors and reviewers and copy editors, and it takes many months to actually get out and get published. So this is a very complicated process, and one of the reasons it's complicated is that it involves passing data around between all these different systems. So what we're trying to do with Overleaf is basically simplify that process by just putting the content in one place in the cloud, and then people get access to it when they need it. So that's the 10,000 feet view of Overleaf. I think now we can get into some more detailed stuff. So I'm going to go through a very quick sort of intro to LaTeX. If you've gone to the website, the ISMB 17 portal, if you go on Quick Start and then Teach Me LaTeX, you will get to the slides. Or if you haven't done that, you can go to bit.ly/overleaf-latex, and that will also get you to the slides. So I'll give you guys a second to get that going while I fiddle with some AV stuff. I need to figure out which side this is on. That's confusing. Okay. So you can just about see this, which is pretty good. Right, so the rest of this, or well, the next bit of this talk, we're going to go through these slides online. So if you're already familiar with LaTeX, this may not be a lot of news to you, but there is also part 2 and part 3 of this course, which you can find linked from the bottom. So feel free to skip ahead, work at your own pace, but I'll go through this stuff. So if you're not familiar with LaTeX, you can learn some LaTeX stuff. Right, so why would you use LaTeX? So in addition to the formatting and the version control, I'd say the main reason people use LaTeX is that it produces really nice looking output. It just looks very professional, and particularly if you're using mathematics, it will format your mathematics to look very nice. It's really the only typesetting system that was created by scientists for scientists, and there's still a really large community of people who contribute to LaTeX and continue to develop it. And one of the reasons that that's true is that LaTeX is very extensible. So you can write packages for sort of discipline-specific things, like if you want to draw an organic molecule, or a Feynman diagram, or a commutative sort of diagram if you're doing group theory. There are LaTeX packages that do all of that stuff. And people have also written slightly crazy LaTeX packages for presentations and even spreadsheets. Although just because you can doesn't necessarily mean you should. It is a lot of fun if you ever want to try writing a spreadsheet in LaTeX. How does it work? Basically, the idea behind LaTeX is that you write your document in plain text, but you include commands in that plain text that describe the structure of the document and the meaning. So then you run that sort of program through a program called LaTeX, somewhat confusingly, and it processes your text and commands and produces a really nice looking output. So if you write, the rain in Spain falls, and this emp is a command on the plane, you run it through LaTeX, and it will maybe decide to italicize that or make it bold, depending on what kind of template you're using, and it will make it look really nice. So LaTeX comes with lots and lots of commands. For example, if you want to make a list, there's a begin itemize and end itemize. We'll tell LaTeX that you're going to write a list, and then each item in the list, you use the item command. So relatively self-documenting, which is nice. And then LaTeX will take care of automatically formatting that for you. Also, there are commands for doing automatically numbered lists. We'll see those later. There's also commands for making figures, so you can include figures into your papers with the begin figure environment. And of course, equations. There are commands for equations, things like Greek letters, and many, many more. We'll see a few examples of those later. So when you start writing LaTeX, if you're coming from something like Word, it does require a bit of an attitude adjustment. Instead of sort of focusing on exactly how things look, it's much more productive, particularly when you're starting out with LaTeX, to focus on sort of what it is, trying to describe it more semantically. So for example, we didn't tell LaTeX that we wanted it to italicize the word mainly. We said we want to emphasize it. And then it's up to LaTeX to decide how to actually map that into how the document should look according to the rules in a template. So that lets you focus on your content, and you should sort of let LaTeX do its job and make it look pretty. That said, LaTeX does provide primitives to basically customize the way that everything looks at incredibly low levels of detail. And that's a great way to procrastinate instead of writing your thesis. But particularly when you're starting out, it's best to try to focus on sort of describing things more semantically. So to get started, basically every LaTeX document is going to start with the same way. It's going to start with a command called document class. So to write a command, you always start it with a backslash, and then the name of the command, and then in the curly braces, what we call an argument to that command. So the document class article means you're telling LaTeX the type of document I'm writing is an article, and it will apply certain formatting rules and make available certain commands to help you do that. Then you write begin document to begin your document, and that's where you can put all of your content. And then LaTeX will stop reading when it sees end document. It's also worth noting if you want to leave a comment in your paper, so something that's not going to actually get typeset into the output, but is still going to be visible in the source code, you can use what's called a comment by putting a %sign. That will tell LaTeX to ignore to the end of the line. So to get started with LaTeX, one of the easiest ways to do it is to start with Overleaf, because at least we handle all the stuff to run LaTeX in the background. So embedded in these slides are these links, and if you click on one of these links, it will open it up in Overleaf, and screen size is a bit small. You can then edit content, and you can see it's very small because it's a whole page, but there's the content there. So feel free to try that out on your laptop and work as we go. That will help a lot. So starting with the basics, how do you typeset text? Basically, you type your text between the begin document and the end document. For the most part, you can just type your text normally, as you would normally type text. Words are separated by one or more spaces, and paragraphs are separated by blank lines. It is important to say that LaTeX will ignore spaces, so it doesn't care whether you put 1 space or 2 spaces or 10 spaces. It will always handle the spacing for you in the output, so don't have to worry about spaces. A few caveats. So if you want to type quotation marks, LaTeX has a slightly odd way of doing that. Basically, you have to use a backtick to get the sort of opening quotation mark, and then an apostrophe to get the closed quotation mark. Double quotes, you just double those up. But other than that, it's pretty normal. The other thing to watch out for is that some characters have special meaning to LaTeX. So we've already seen one, the %sign, which tells LaTeX to ignore to the end of the line. There's also the hash, the ampersand, and the $sign, which we will see a bit later on. If you do actually want to type one of those, you have to do what's called an escape by prefixing it with a backslash. And then LaTeX will know to actually put it into the output instead of interpreting it. If you forget to do that, that's one way that you can end up with a LaTeX error. So basically, if LaTeX is reading your document and it gets confused because it sees something it doesn't understand, it will stop and it will give you an error message. Often it's quite a cryptic error message. So for example, if you misspell emph as something else, it will say undefined control sequence, which if you stop and think about it, maybe you can think, okay, it's seeing something, mef is a control sequence, that's a command, and it doesn't know what it is, undefined, it doesn't know that command. So basically, if you get an error, as you probably will at some point in your LaTeX career, don't panic, they are normal, they happen. The main thing is to fix them as soon as they arise, so don't let loads and loads of errors build up, because then it can be quite difficult to figure out where the error is coming from. And if you do end up with multiple errors, always start with the first one, because once LaTeX gets confused, it gets even more confused later on, and it's unlikely that the error message will be very helpful. So with those words of warning, there is a typesetting exercise. So if you have your laptop open, you can click on this button and open this exercise in Overleaf, and it's got the text in it. Oops, doesn't like the small screen. But you'll see you have some errors, and you can spend a couple of minutes going through and trying to typeset that. So I'm going to wander around and see if anyone's doing it. If not, then we'll give up and keep going. But I'll give you guys a couple of minutes to work on that. looks like lots of people are making good progress on that. I'll just quickly go through it here. So the first thing, missing dollar inserted, is quite a cryptic thing, but because $ is special, you have to escape it. And there's one more here. And %, you can see LaTeX is basically just ignoring to the end of the line, which is not what we want. We actually want a %. Bonus points if you notice that the quotes are not quite LaTeX quotes. You can change those to backticks and apostrophes. And then we'll see whether I've got all the bits. There we go. Quite hard to see, but hopefully that looks about right. Okay. Right. So moving along. Typesetting mathematics. So this is one reason a lot of people use LaTeX, so worth covering. Basically, the reason $ are special is that they tell LaTeX that you're going to write some mathematics. So if you write your mathematics without $, then it will still sort of work, but it won't be very nicely formatted. If you do put it in $, you'll notice that LaTeX will italicize the math for you, and it'll also tweak lots of subtle things like the spacing, the way it wraps lines. Instead of a hyphen, you'll get a nice minus sign, things like that. So always put your mathematics within $ if it's in line. It's very important to always use $ in pairs. If you have one $sign that isn't closed by another one, then you'll get some very confusing errors, or your document will suddenly be all italicized. So that's something definitely worth bearing in mind. And again, it's worth emphasizing that LaTeX automatically does all the spacing for you. So it doesn't care whether you type this with no spaces or lots of spaces. It will automatically handle all the spacing for you. LaTeX does provide commands for tuning the spacing in lots of different ways. And you can read more about that online, but most of the time it does the right thing. If you want to type a superscript, that's a caret, usually is shift 6. A subscript is an underscore, so if you want to typeset something like a polynomial, you can use underscores and carets to get the subscript and superscripts. If you want to make more than one character a subscript, you need to use curly braces. So if you want to write Fibonacci sequence here and you don't use the curly braces, it will give you something slightly wrong. But if you do put the curly braces around the subscripts, it will group them nicely for you. And there are lots of commands for Greek letters, so things like mu and omega. So big omega with a big O will give you an uppercase omega, and omega with a lowercase o will give you a lowercase omega. There is also a special way of writing a sigma, which is the sum command, which will give you a nice sum with the subscripts and superscripts nicely positioned. So that's how you can write a sum. If it's big and scary, then you probably want to use something other than $. You want to use a begin equation or end equation, begin equation and end equation. Basically, you sort of begin equation and then you write your scary thing, and then it will typeset it on its own line and it will give it a number, so you can refer back to it. One caveat to that is that while LaTeX mostly ignores spaces, if you have a blank line in an equation environment, very strange things will happen, so it's best to avoid that. That's a minor tip. You've probably noticed me use the word environments a few times. So basically, an environment in LaTeX is like a context. So the same command can produce different output in different contexts. So if you write, for example, this equation in inline math with $, you notice it looks like this, but you can write exactly the same commands in an equation environment and it will look totally different. It'll use a bigger summation thing, it'll have more space. And so that's basically how LaTeX handles lots of different environments, but in a consistent way. And in fact, a lot of things are environments under the hood. So if you wanted to, although it would be very verbose, you could actually replace your $ with begin math and end math. But that's not usually something that people do. There are lots of other environments, some of which we've already seen. So begin itemize introduces, in this context, an item command. You won't be able to use the item command if you're not in a list environment, but you can also use the same item command, but in a different environment to produce a numbered list, for example. And LaTeX automatically handles all the numbering, and there are lots of ways to customize the number styles and stuff like that if you you look it up online. Where do those environments actually and commands come from? So most of what we've done so far has actually been built into LaTeX. There's kind of a LaTeX core package, but there are lots of other packages that people have written in the community, many thousands of them. And if you want to use one of them, there's a special command called use package. That command has to be used in a specific place in your document. It has to be used between the document class and the begin document. We call that part the preamble. So in this example, we're going to load a package called AMS Math from the American Mathematical Society, and it provides us with all sorts of useful stuff. So earlier we said if you use begin equation, end equation, it will automatically number your equations. If you don't want it to do that, because you don't need to refer back to it, there's a special equation star environment that doesn't have a number. And that's kind of a convention in LaTeX, is if it has a star, that means no number. Although not always. LaTeX treats adjacent letters as variables multiplied together. So this can be challenging if you want to write something like min to minimize. If you just write min, you will get basically m times I times n and typeset it that way, which is probably not what you want. But AMS Math provides this nice \min command, which will typeset it in a non-italic font and will also fix all the spacing for you and all the subscript handling. So that's a very useful command to know. There are also lots of other operators in the same sort of vein. So if you wanted to define something like covariance, I don't think there's a built-in operator for that, but you can use the operator name command, which takes 2 arguments. One of them is, or sorry, no, it takes 1 argument, and then the rest of it is sort of set next to it as the argument. But anyways, you can send covariance as the operator name, and it will automatically typeset it for you in a nice way. Another common feature request is to align a sequence of equations. If you're deriving something, you want to make them all align with the equal signs. You can do that using an align or align star environment. If you don't want a number, you can use align star. And this is where we encounter the ampersand for the first time. This was another special character. LaTeX uses this basically to align things. So when LaTeX reads this, it sees x plus 1 cubed, and then it sort of establishes a rule along the ampersands, and then it typesets the rest, the equal sign and the definitions. If you want to break a line in a math environment, you can use a double backslash. That is a line break. So that's another useful trick. And then it brings us on to another exercise. So in the interests of time, I think I will assign this one as homework, but you guys can continue working on it, and I will demo some stuff on Overleaf. But by all means, continue working away on that in the background if you'd like to. This is also pretty much the end of part 1, but there are also part 2 and 3, where you can find out how to write a document with sections, so things like sections and cross-references and labels, and also figures and tables and bibliographies. So definitely worth checking out part 2 if you are interested in that. Right, so some other stuff you can do on Overleaf. I think a good place to start is our template gallery. So when you're starting a paper, it's usually a good idea to start from a template, because people have already done a lot of work for you. We have lots of different types of templates, many for things you might expect, like academic journals. So scientific reports, for example, IEEE papers, I think there are several thousand templates on there now. So you can open one of those and get started very easily. But also interestingly, LaTeX does lots of other things. You can definitely do your CV and make it look nice. There are some pretty crazy things you can do, like build yourself a dodecahedral desk calendar, which you can print and cut out and put on your desk. There's lots of other good stuff in here as well. Like these folding floppy disk jewel cases. Very good. Very useful. So definitely check out the template gallery as a good place to get started. If you are in a document on Overleaf, I've got one open here. This is just our sort of default template. I'll just hide some of this stuff to give us a bit more room. By default, Overleaf will open in rich text mode. And that means basically we're sort of hiding away some of the LaTeX commands under the hood, but you can still edit in rich text mode. And if you look at what happens in the corresponding source mode, you can see that we are editing a section tag, and it's basically just formatting that nicely for you in rich text mode. Some other things we do in rich text mode, one of them is comments. So if you are in your document, you can always select some text and hit this comment button, and this will create a comment where you can quote that. You can leave a message. And it is a sort of little threaded discussion, so I'm going to have a discussion with myself. But obviously you can invite your collaborators by sharing the link to the document, and then they can comment as well. I agree. Once you're done, you can click close, and that marks it as resolved. And it's still there for reference, but if you want to delete it, you can just basically backspace over it, and that will get rid of it. We also show you the figures as a preview when we can. LaTeX tables coming soon, still not quite done in rich text mode, but that's definitely on our radar, and I'll talk a bit more about that at the end. Mathematics will also show you a sort of inline preview. So basically, if you move your cursor into the math, you can make a change, and then if you move it out again, it will update. So that's an easy way to get a really fast preview of an equation that you're working on. Sections and subsections, it also handles, it has a reasonably good job of lists, and it will also do things like citations. That brings us on to reference management. So if we go to the project menu, I think the best way to manage references is to use a piece of software like Mendeley or Zotero. So you can always add things to that software and build up a database as you read. Overleaf integrates with those. So if you go to Project Files Bibliography, you can select one of our bibliography partners. I'm going to connect my Mendeley account. So basically, if I do that, it's going to send me over to Mendeley. If I log in, it's going to let me either import a group or just import my whole library. So, and I get to choose the name of the library in my project. So I'll just call it mendeley.bib. I think I have quite a few things, so it may take a few seconds to load that. But once it does, oh, it's a lot faster than it used to be. That's good. It has imported all of my references as BibTeX, and everything else I can pretty much do in the standard LaTeX ways. So if this one still requires a bit of fiddling in source mode, but if I use the bibliography command to tell LaTeX where my bibliography entries are, I can tell it to use Mendeley, and then if I want to cite something, it will automatically complete from the list of references that I've loaded in my bib file. And then once I've done that, if I get the preview back here, it will have updated. I will just use a command to jump over to the right place in the PDF. If I go, okay, I'll use the keyboard shortcut. Control comma will find the right location for you in the PDF, and you probably can't quite read that, but it has put in a nice citation for me in the style that I selected, and it will also have automatically formatted that reference for me. So LaTeX has really good support for automatically formatting references, and it's a really good idea to use something like Mendeley so you have that database of references to draw from. Right, so that's reference management. Also, before we get too far away from it, we showed you one way of commenting on your paper in Overleaf using those sort of rich text comments. As I mentioned, we've actually just merged with another editor called Cherrylatech, and they've got a really great feature that does that in a slightly different way. So I've switched over to Cherrylatech here. If I just make this a bit bigger, you can see it's a sort of similar idea. You edit here the LaTeX code, and you get a preview of the PDF on the right. And if you select some text, there is an add comment option, and it pops it up in a little sidebar. We'll try to make a bit more room here. And you can leave a comment in the sidebar. That's unfortunate. And you can have a little threaded discussion in the sidebar, much the same way. They also provide, as a paid feature, what we call track changes, which works very similarly to Word. So once track changes are turned on, any changes I make to the document will be highlighted and can be accepted or rejected. So this is something that looks a lot more familiar to people coming from Word. And so it's a good idea. If you're working with someone who wants track changes, you can try out Cherrylatech, and they will also hopefully find this useful. We are working with the Cherrylatech team to bring this kind of functionality into Overleaf and merge the two things together. But for the moment, you've kind of got two different choices, and you can pick whichever one suits you the best. So there we go. Another thing that Overleaf supports is offline working. So if you want to work offline, one of the things you can do is go to the Share menu, and every Overleaf project has a Git link. So if you're familiar with the Git version control system, you can take this link and switch over to your terminal, which I will hopefully be able to put on here. There we go. Okay. And then we can just do a git clone from that. And now I have got that project on my computer, so I can work locally. I can do all the usual stuff. So if I now edit the main file, and I don't know, maybe I'll change the title to Your Paper Written Offline. I can then commit that. Change the title, and if I push it back up to Overleaf, and I switch back to Overleaf, oh, I have to close that, we will find that, oops, it is automatically updated online. So basically that's a good way to work in your favorite LaTeX environment offline, but still collaborate with people online who don't have LaTeX installed, or who want to use the rich text mode. And if you, yeah, it's also worth saying, so if people are editing the document online, so like I make a change online, and then I also try to make a change offline. I don't know, I'll put my name in and say that I added my name, and then I try to push. Overleaf won't let me do that because someone has already changed it online. So basically, we put the onus on the Git user to sort out any conflicts. But if I do a Git pull, I can merge the changes that were made on Overleaf into my local repository, and then I can push it up to Overleaf. And now both of our changes will be reflected. So my name has showed up, and I've still made this change online. So that's a very powerful way of using Overleaf if you want to work offline. For example, when you're at a conference or on a train or plane or whatever. Finally, if you have written your paper on Overleaf, there's also the Journals and Services menu. So one of the things you can do is you can submit your paper to the Overleaf gallery. You can submit it, just treat it like a preprint server, but most people who submit things to the gallery submit things like templates. So if you run a conference or you're submitting to a conference that doesn't have a LaTeX template and you've put in a lot of effort to make a LaTeX template, please consider publishing it to the Overleaf gallery so others can use it. We also have integrations with a number of actual publishers. So F1000 Research, for example, is an open access publisher in the life sciences. I'll give you a demo of that in a second. We also have quite a few other journals that you can search and submit to, so things like PeerJ, another open access publisher, scientific data, scientific reports. We have partnerships with all of them. And you can also search for things in your area. So for example, you can find biostatistics, biological chemistry, Journal of Mathematical Biology. All of those are publishers or journals that we have partnerships with. If we have, oh yes, and I should also mention, if you scroll down a bit more, there are several preprint servers you can submit to, such as the bioRxiv. So there's a sort of not very streamlined, but a little bit streamlined submission process for them. We are working with them to do more. Also, you may be interested in trying out author services. So if you want someone to check the statistics in your paper or to review the language, you can use a company like Inago or Editage and invite them to your project on Overleaf, and then they can make changes, and you can collaborate with them that way. And there are quite a few options you can choose from there. If I give you an example of a streamlined submission process, so F1000 Research is one of the nicer ones. Basically, if I submit my paper to F1000 Research, this is just some information about them. If I click the button, I will have to sign in on F1000 Research, which I think I do with Google. And you can see Overleaf files are being uploaded in the background. And it's also pulled out my, I see someone has added a smiley face, that's good. My title, and a little bit about my name from my Overleaf account. So one of the things that we do with our submission partners is to try to relieve you from having to rekey all the metadata every time. That's very frustrating. So we try to extract it from your paper and pass it across. So that you still have to check all the other boxes, but at least some of them we can do for you. And you can see in the background we've uploaded your PDF file and also all of your source files so that the LaTeX, so that the F1000 editors can access them. Also with F1000 Research, they do post-publication peer review. So the initial sort of process is that their editors go into your Overleaf project and they use the rich text mode to sort of leave track changes and comments. And then you actually do that back and forth with the F1000 Research editor, all within Overleaf. So it's quite a nice flow with F1000. I won't hit submit because then I would have to actually pay. But great. Okay, so I think that's it for demos. I'm just going to switch back to slides for a couple more points, and then we'll be all done. I'm going to skip through large numbers of backup slides in case the Wi-Fi didn't work. I mentioned tables. There isn't a table generator in Overleaf, but if you Google, there are lots of websites that you can use where you can sort of put in all of the stuff in a table and it will generate the LaTeX for you. So if you Google LaTeX table generator, you'll find a few, and they're all pretty good. So we're still working on integrating one of those. Another cool integration we do is with Plotly. So they're like an online collaborative plotting platform. And they've written all these libraries that let you sort of submit your plots to Plotly from all sorts of plotting packages like IPython notebooks and R. And you can pull them into Overleaf projects. That's pretty cool. Another thing, particularly if you're getting started, you may not yet know all of the thousands and thousands of LaTeX commands. I know I still don't. So there's a site called Detexify, and you can basically draw your command, and then it will look it up and suggest to you which command it might be. And that's really fun. For more advanced LaTeX users, there are also quite a few sort of advanced options. You can use different LaTeX engines. So there are lots of different types of LaTeX. Most of the time, Overleaf will figure out which one you need and just use it. But if you want that extra power, it is there. And there's some interesting stuff on our blog, blog/500, about all the different engines and what makes them special. Mainly, they support Unicode better. But there's also lots of other nice things. Finally, if at your institution you're working with others on Overleaf, you can add your affiliation to your profile, and that will give you access to a sort of portal for your institution on Overleaf. And from there you can find templates and things like that that are specific to your institution, and you can also help us by showing your support for a site license at your institution. There's a one-click form that you can do, and that will help us approach your library or other ICT function to get something installed. Anyway, you guys, you all have free Pro Plus accounts if you followed this link and clicked the button and signed up. So don't forget to do that. thanks very much, and I'm very happy to answer any questions. Yes, there is a spell checker. I can give you a quick, figure out where I am, a quick demo of that. So like if I misspell something, it's actually still a word. There we go. If you right click, it will automatically suggest things. You can also toggle languages, and there is a custom dictionary that you can use.
An important thing. So what does Pro account add?
Pro account, good question. So one of the things it gets you is more space. Another thing it gets you is more options for controlling access to projects. So by default in Overleaf, every project is private. It comes with a secret link, which all you have to do to share the project with someone is send them the secret link, so it's very easy to share. But if you have something that's more sensitive and you want sort of tighter control, you can make it what we call a protected project. And apologies to whoever else was editing it, because you've now been kicked out, sorry. But then you can add people by email address, and you can also choose whether they have read access or write access. Another useful Pro feature is full project history. There is not actually a lot to show you, because I just created this document 5 minutes ago. But if you have a long history on your document, there will be a sort of timeline view. You can see who's edited this week, this month, this day. And you can also always get back to a recent activity feed, which shows you all of the edits that have been made in the past day or so. And then you can keep scrolling back as far back in the history as you want. So those are the main Pro features.
So these comments, like where you wrote that funny story with yourself, are they visible if you do use VI and Git, or are they only visible in the web interface?
They are still visible. They are a little bit less pretty, but where to go? Yes, it's over here. I'll show you one. Oops. Oh, really doesn't want me to leave. Yes, so there's a rich text comment here, and if I look at that in source mode, line 35, it's still kind of there. It's just a specially formatted LaTeX comment, so you can still kind of do it in Vim mode, but it's kind of manual. And since someone asked about Vim mode, there is also a Vim mode on Overleaf. You can choose between Vim and Emacs. The Emacs bindings are not great, but the Vim bindings are pretty good now, I think. Someone over there.
Can you connect your references also not just with Mendeley, but for example with Citavia?
So at the moment, so you can definitely upload a bib file from any program that will export bib files. We also integrate with Zotero, SiteUlike, and Mendeley at the moment. So if we don't yet support your favorite bib manager, you can let us know, and we'll try to contact them, and of course let them know as well that you would like them to support Overleaf, and that will help us. Great. Thank you.